I just figured I'd put this up because I really like that. I also recently got into emoji. Yes, I'm that guy. It's like how Ruby won't whine at you if you ask it for a scalpel. It'll just give it to you, sit back and wait to see what happens. I also figured I'd get the trolling out of the way up front. So my name is Quintis. I am QV almost anywhere that matters. GitHub, Twitter, etc. I'd like to set some expectations up front. If you were expecting Aveshan up here, he's not here. My apologies. Sorry, not sorry. This is not a recruiting talk, right? Let's sort of deal with that. I will be talking about where I work, what we do, because it's relevant to this talk. So I work at Jumo, where we use behavioral data from mobile usage to create financial options for people. Mostly people, so for 80% of our customers, interacting through the Jumo platform is the first time they ever interact with a bank. Not that we're a bank. So we use the technology that connects everyone. They interact with us via USSD, and we provide them with previously inaccessible financial options. These are some of the stats I grabbed from our website yesterday. They obviously would have changed by now. I put them up here to help set the stage for some of the topics we'll be talking about, which is largely about how to deal with growing environments. Some of the challenges we face in growing environments technically, as we're not going to talk about the non-tech stuff as much, since there's not really that much time for it. So when I was asked a week ago to kind of cover for Aveshan, I figured, okay, so what the hell to talk about? And the Ruby community is pretty amazing, actually, at just producing stuff, whether it's utilities or frameworks or security tools. Kind of seldom, okay, mea culpa, I have not been to a Ruby conference in a while. But rarely are there talks, just honest talks about mistakes we made, the things we did wrong, the silly things we're afraid to admit. So we're going to try and do some of those today. This was the actual title of the talk. Ruby and finance, okay, whatever. I would like to kind of reclassify it right now, and I would rather title it like Embrace the Chaos or something like that. So I had an idea for what the title might be, so I put it down into emoji, and then I was pressed for a title by the organizers, and I was like, damn it doesn't go backwards. This is like a one-way hash going from English to emoji, right? It's really difficult to get back, so we ended up with Ruby and finance don't mix. Okay, so where was I? Sorry. Right, so I'm going to start one of the major debates we've had recently, and it was actually really funny if it weren't a major debate. It was about, I call it violent, riotous debates about not using Ruby for finance, right? We were looking for typing, et cetera, et cetera. This was one of the arguments that was proposed. So specifically for the financial parts of our sort of ever-evolving architecture. Excuse me. And the cool thing about me being up here and not Aveshan is that my events of what happened is what really happened, all right? So here's how it went down. The debate, like I said, caused quite a riot. Well, maybe not quite a riot. Okay, it wasn't violent. A few people were really opposed to the idea of switching to a statically typed. Okay, it was me. Okay. That's, as far as I'm concerned, the problem wasn't the language that we were using. The problem was a fundamental lack of confidence in our existing outdated big monolithic Rails application. Who knows what I'm talking about? Yeah, I see some heads going, great. Okay, so, right, confidence, we're done. Thank you. Be confident. Thank you, guys. Okay, so it's about confidence, but what is it that gives, yeah, why aren't you guys clapping? My colleagues are sitting here going, thank you. So where does confidence come from? Is it just a good test suite? Is it a sort of evolving architecture, what is it that gives us that confidence? And as you know, the confidence, as in the consequence in a technical sense, is backed by a shocking number of different things. Even if you limit the scope of that discussion only to technology. So let's backtrack a little for some context. Why is my thing not working? Come on, thing. Thank you. There we go. All right. So there's no code in this talk, so just pretend that's code. This is not as... Was that going to be a clap? I'm open to applause anytime. As you can tell, I need this, right? So this is not as low level as some of you might want it to be. Like I said earlier, I'd like to just honestly share some of the decisions we made, some of those that have bitten us, some of those that have worked out really well, and then sort of underline some fundamental things that help us through this process. Also to let everyone know that it's okay to not know everything up front, right? It is 2017. It's knowing a single programming language is not good enough. Knowing a single toolchain is probably not good enough. Not worrying about your runtime environment it no longer cuts it. So there's a hell of a lot we need to know about. Whoops. Whoa, where are you going? Sorry about that. In our case, we went from 50 to over 200 employees in the past year. It's quite big. I mean, we start from 50, right? The 150 delta is not the big deal here. The big deal is that it went to 200 from 50. So from an engineering point of view, we went from 10 to n engineers. N is undefined at this point, at close to warp scale, or warp speed rather. And I mentioned the monolithic code base, so you can already tell where this is going. And if your organization is growing really fast, then your infrastructure, your architecture, all these things need to keep up. And we have all these, everyone online, the whole internet, every organization out there has the right way to deal with these things. We don't have that much time. No one has that much time. This is almost like OO principles where you can't apply all of them all the time. Not because you don't have time, but because some of them are mutually exclusive. So Wikipedia refers to this hyperscale as an architectural ability. I'm generalizing it a bit here. So I mentioned the monolithic Rails code base, and confident engineers that we are, we say, awesome, let's do it. Right? Those 4 words, those fateful 4 words. Let's fix this problem. The consequences have been, like I alluded to earlier, there have been some good ones, there have been some bad ones. There have been some fun ones. So what are the ingredients that allow us to do all of this stuff? And, well, I know this one. And the answer is it depends. Right? It always depends. In this case, well, yeah, this doesn't come as a shock to anyone, I guess. This slide essentially says one thing. The output is directly correlated to a function applied over the input. All right, what you put in, essentially, is what you get out. To co-opt the common phrase, garbage in, garbage out. So companies like Google, Amazon, Facebook, and countless others have taught us a lot about growth and how to deal with it technically, how to deal with the team aspects, how to deal with architectural or infrastructure aspects. And this is all copy and paste, right? Because we like copy and paste. Well, of course not. This talk could have ended at so many points if any of those things were true. So in these conditions, we have to constantly reassess and question decisions that were perfectly valid a month ago, even last week. So when we're going from 10 to n engineers at warp speed, scaling could mean take on more partners. It could mean screw it, we'll deal with the fallout later. Let's just get this feature done. All of those approaches, all of those intuitive almost or reactive approaches is equal to one thing, tech debt. And as we know, tech debt just gets smaller with time, so it deals with itself. Yeah? Thank you. I want to find out what your secrets are. So one code base with relatively few but well-defined code paths it means a few things when growing at this rate. For one, engineers constantly smash into each other's code, right? They constantly walk all over each other. And this is horrible enough in day-to-day operations, but when you're growing this quickly, it's one of the few things that it's rather innocuous, right? It's one of the okay things to deal with when this happens. So since this talk isn't about OO or design principles, well, this, by the way, this is the hand wave. I kind of expect Miyagi to show up when I do this. Yeah. So when I hand wave, I'll just do this over something. OO and object-oriented principles and those things, we're hand waving over that. So instead, we're going to talk about a sort of well-defined but often misunderstood or often ignored part of any scaling strategy, and that's automation. So automation of various kinds get a little bit easier when you're on a single runtime platform. Heroku is a great example in this community. So Heroku has served us incredibly well, incredibly well. Although with like 100+ dynos and auto-scaling services or auto-scaling workers with services like HireFire, you're going to outgrow them at some point. Heroku is a great example here, not because it ended up, or we outgrew it, and therefore it's not good enough. It's an amazing service. But their offering kind of skips a level, which is fascinating. So Justin over there talks about this fairly often, where you don't get small, medium, large, extra large, XXL. You go from small to medium to XL. Right? So you kind of have to start reevaluating those decisions. And I also mention Heroku specifically here because at some point, you have to kind of take a step back and realize that it's okay and accept that not everything is within your control. You could do everything perfectly. You could execute perfectly. Heroku, where's our middle offering? Yeah, sorry. Right? These are things we need to deal with. So as many things as there are that are outside of our control, decision-making is not one of those things. Right? Let's just accept that up front. So I want to say a quick word about CI and just automation tools and platforms in general. For any non-trivial code base, and this is purely me kind of soapboxing, for any non-trivial code base, if you don't have at least CI, just consider your entire code base tech debt. Okay, just start there. Regardless of your tests, actually. So we made what I think was a great decision to reassess some of the CI tools and general automation tools that we were using. Also, tools that have served us really well, but now you start queuing for builds and things like that. So you need to move on. Of course, after that, what we considered to be a great decision, we went right ahead and screwed it up immediately. And we did that by saying, well, there's plenty of reference documentation out there, right? This is a really well-documented solution. So go forth and conquer. It's implemented, we're good to go. Engineers don't want to hear that. Teams don't want to hear that. No one wants to hear there's plenty of good documentation. So a really valuable lesson is always have a reference implementation or an example somewhere. We're going to come back to this thing over and over and over again, but it's this idea of constant and quick experimentation. This is one of the key things that enables that. So what are we automating? So we're not skipping architecture completely. We're coming to that later on. But I've mentioned services like Heroku and using HireFire to auto-scale your workers and so on. And it takes care of a lot of infrastructure needs for you. When you're constantly changing, or when you're constantly sort of adapting to changing requirements, changing environments, a few things become really important. That on services like Heroku, you don't really care about that much because it's baked in. Things like logging and monitoring. Right? If you're now moving to a service that doesn't have those things baked in, it's a really important thing. It saved our bacon so many times. So clearly define the metrics for measuring the state of the world. Right? Whatever those metrics are, it doesn't matter. Well, of course it matters, but that's not the relevant point here. So let them drive things like your alerts. And we're doing this for false positives on alerting solutions. All right, just hand waving over. So other services that have really served us well in the past are services like Sumo Logic and New Relic. Actually, still New Relic. And there are lots of good options out there to make it really difficult to make good decisions without constant experimentation. As an example, assuming you have some kind of, I don't know, containerized environment, and assuming you're on a platform like AWS, do you go with ECS for your runtime, or do you do like Swarm or Kubernetes or Mesos or some other orchestration mechanism on top of EC2? Unless you experiment, spec sheets for those products aren't enough to make a good decision, so experiment. Which brings us to the next part. Manageable architecture. So we satisfied the cloud infrastructure requirement. That was our requirement, okay? So now we're good. So what about the application architecture itself? When you think about architecture in 2017, I'll try to steer clear of the M word, but sort of service and cloud-based architectures come to mind. And by M, the M word's not manageable. It's the other M word. So the problem is solved, right? We perform some monolith to services incantation, and we're good to go. The world's a better place again. Yeah, lots of smiles. Or they could be smirks, actually. Generally speaking, eagerness is an awesome attribute. Well, generally speaking. So I want to share a little story about eagerness, and it involves gRPC. So we're in this culture where we constantly experiment. We constantly build proof of concepts, etc. So now we've got this, we've committed to building this gRPC concept or proof of concept because we need some sort of typing or typed interface for API, and what the hell, services are chatty, so we might as well just deal with that as well, right? Now we're experimenting with various sort of AWS services. Raise your hand if you know where this is going. AWS plus gRPC. All right. So we made an obvious mistake. I guess we could call it an error of expectations. Just because platforms and services integrate so well, everyone integrates with everyone else. Everything integrates with everything else. Services just work individually. The error of expectation here is that those things that just work individually will just play well together. Not always the case. In this case, no. So you put your hand up. Do you know what happened next? Yeah? Okay. So at least for us. Someone had something here? No? Okay. Sorry, I thought I heard something. With all these different sort of requirements in mind and thinking about infrastructure and architecture and teams, all of the non-tech stuff as well, this was a highly non-obvious thing for us. And here's what happened. gRPC doesn't support HTTP 1, right? It requires HTTP 2 because the way it persists connections, does multiplexing, and so on. So the ELB on AWS was not happy at all, right? Suddenly, load balancing, a really well understood and well-defined problem, becomes an overhead that you shouldn't have to deal with. So again, same lesson. Experiment quickly, experiment often. Spec sheets wouldn't have been enough. Actually, it might have been enough to give us this, but we also have this kind of error of expectations going on all the time. So still, it's now trade-off time. So what do we have to trade with? What's it between JSON over HTTP and gRPC on the other end? Well, protocol buffers, right? So another story. This is one that actually turned out quite well. On its own, it gives us the message serialization, deserialization. If you're not familiar with protobufs, that's basically all you need to know about them. And the missing part is the context that gRPC gives us. So, excuse me. Protobufs is, I mean, it's relatively simple. But there are services, so making the decision was actually really simple. It actually works. It works with our infrastructure choices. But also the number of services that speak gRPC are very, very limited. right now at least. So the general lesson we took from this is that, aside from just the experimentation, is that technical compromise doesn't mean you lose. Right? Take the win. Always, always take the win. It's such an obvious thing and something we rail against time and time and time again. Let's do this. No, let's do this. No, let's do this instead. And eventually someone's going to win, and very likely there was some element of technology bias or ego or something else involved in that decision. Take the win. So, what are we on? 21 minutes. I believe I had 20? Okay, I'll get through this. I've shared some of the stories, but over the holiday period, I was going through all my GitHub repos. I had like a personal hosted Git elsewhere, and I had tons and tons and tons of repos in there, and I decided to do some cleaning up. And I sort of bumped into this question very, very often. All of the things we have to think about to, even just from a technical perspective, help us scale, help us arrive at some correct architecture based on our requirements, all those things ignore the really difficult things, the human bits of scaling organizations, teams, etc. And my brain hurts just thinking about this stuff. So why are we doing this? All the code in all those repos just scattered everywhere. What's the point? So I've been bumping into dead code very often, and I've been thinking a lot about dead code. When I hear dead code, the first thing I jump to is, okay, there's something obviously I need to refactor, I need to go remove something somewhere. Seeing all these repos of mine, it's entirely possible that your entire code base is just dead code. That entire repo is just dead code. So why do we go through all this hassle that makes our heads hurt? On an individual level, I might say, you know, because it's freaking awesome. And it is. Or some, I don't know, cute double negative like, because I can't not. And all of that is great. You can get most of that awesomeness, most of that because I can't not, from working on projects that don't require all of this to this extent. Right? You don't necessarily require 400 instances of some virtual server somewhere. So for us, organizationally, it's a more difficult question to answer. For us, it's easy, right? It's pick any one of a million things. Someone gets to send their kid to school. Someone gets to finance their crops. But it's a question I want us all to constantly ask ourselves. There's the number of tools and technologies out there that can help us do what we do. Whoa, I messed this up. There we go. I think. Yes. That was planned. Okay. So ask yourselves the question, why do this? All of this stuff is hard, right? Some of you in this room are absolutely wizards at one thing, at many things. Not all of us are. Very few of us are wizards at more than one of the things we've talked about today. This stuff is really, really, really hard. I can't see myself just constantly producing and producing and producing code that just ends up dying. So I'm going to get off my soapbox, but ask yourself, why does your code exist? And with that, I'll take questions if there are any.
So you mentioned objective.
Yes, my friend.
How do you balance tech debt versus product features? Do you have product managers that are trying to push you to produce new features, and then you have development managers who are trying to deal with tech debt?
I want to say lie, but don't lie. Yes, that's one part of it. And I mean, organizations approach this topic wildly differently. But in our case, for example, we have product owners that try to the extent possible, isolate us from pushes from the business side. So product owners very often come as sort of part and parcel of business. I would love to just move them out, just get them away from business, have them be like some kind of hardware abstraction layer between tech and business. Lie a little bit maybe, right? But don't overestimate, because that then causes another lack of confidence issue, but this time from business side, which is kind of the worst position you can be in, right? So I don't have an obvious answer there. Yeah. Anyone else? Anything else?
So you said you had a monolith, and you said you were scaling to M.
Yeah.
Are you changing your architecture?
Yes. Yeah, so I try to not say the M word, but some service-based architecture. It makes it really easy to scale down teams. If all devs are just trampling all over each other's code and bashing into each other, then it's probably just because you have too many people working on the same thing. So scaling that team down and clearly defining those things really helped. Any more? Soon. The answer is no. Okay, the honest answer is no. But you're not the first person to raise that, and internally it's like a huge thing right now. I don't want to air dirty laundry, and this is not necessarily dirty laundry. I feel many organizations actually struggle to deal with this issue. How do you make yourself attractive? And part of it is publishing. Part of it is contributing to the open source community, contributing tooling, contributing to tools you use. When you already have product pushing, get features out, you have a huge tech debt backlog you need to try and deal with. How do you prioritize those? So it becomes what's more important, short term, let's get features out, or a medium term, or long term. And depending on what that vision is, whatever's going to help you get there. So yeah, really important, and we will soon. Anything else? I want to do this one more time. Yeah? Thank you.